rule or procedure you can follow for those of you who are not good visual learners, okay? And so hopefully one way or the other this will make sense. I'm going to have to start this over so it will quit freezing up on me. So hang on one second. All right, let's try this again and see if it'll work. Yes. Okay, so the very first thing that we're going to talk about today is similar triangles. We're talking about similar triangles, but now we're going to focus on specifically right triangles. Chapter 8 only has 4 sections that we're going to focus on. There's actually 6, but for time purposes, we won't do 5 and 6 unless we have time at the end of the school year. And then we'll go back and look at 5 and 6 as kind of an extension to get you ready for pre-cal. You will learn sections 8.5 and 8.6 in pre-cal. So if we don't get to it, Mrs. Stennett will teach it to you for the first time. But there are 4 sections, and they are all about right triangles. So this entire chapter is about right triangles. The only vocabulary word we have today is geometric mean. You're going to have to find the geometric mean. It'll take us back to radicals and simplifying radicals. We're going to start this lesson off with, though, a special kind of right triangle, and I'm going to show you how you can connect what we just learned about similar triangles to right triangles, and then we're going to learn some shortcuts. So I'm going to start off with, this is the long way to do it. The reason I'm going to do that is because on the homework and on the test, you are going to be required to write a similarity statement for all 3 triangles. And the only way to do that is to look at it the long way. Once we learn that, though, I will show you a shortcut for actually finding missing measurements so that you don't have to work it the long way every time. Okay? So, special kind of triangle we're talking about today is a right triangle that has an altitude drawn from the right angle to the hypotenuse. So if you look at the picture, notice you have a right triangle, and then they draw an altitude over to the hypotenuse, and that altitude forms a right angle. Back when we talked about altitudes in chapter 5, remember it goes from the vertex perpendicular to the opposite side. And when it does that, what it creates are 2 more right triangles. So in our picture, we end up with 3 right triangles. And what we're going to learn today is when it fits this special model, it creates 3 right triangles that are all similar to each other. And they're all going to be similar to each other by angle similarity. And I'll show you where those angles fall into place. Obviously, one angle they have in common is what? The right angle. They're all going to have a right angle. And then I'm going to show you where the second angle comes into play for each scenario. And for those of you who don't see things very well visually, by turning the triangles, you can focus on the angles that match up, and that'll help you. So what our goal is we're going to try to come up with this similarity statement. So right now, pretend that this is not here in your notes, and we're going to try to visualize these 3 triangles separated and matching. So I'm going to redraw for my visual learners. I'm going to redraw. So if I were you, I'd draw this down with me. The great big triangle, and let's relabel it. So this is B, C, and A. And then I'm going to talk about the other 2 triangles in the picture. So I'm going to label those triangles 1 and triangles 2, just like I did up at the top. And I'm going to redraw those 2 triangles, but matching it up to look like this triangle. So for example, if I take this triangle number 1, if you look at it compared to the great big triangle, what angle do they have in common that is the exact same angle? A. Does everybody see that angle A here is the same angle in the great big triangle and the little triangle? So I'm going to take this right triangle and I'm going to flip it over so that the right angle is down here and angle A is over here, so that it looks just like this triangle. So I'm going to take this, flip it straight down. So if you can see that visually, that makes this right triangle here. That makes this vertex of the right angle what letter? D. And then angle A is now facing the same direction, so this is A. And what's the letter up here at the top? C. Okay, if you're not very visual, think about my angles have to match up. So we just said this angle A and this angle A are going to be the exact same angle, so we're going to put them in the same spot. You with me? And now do you see that these two triangles will be similar to each other by angle, angle similarity? Okay, and this was triangle number 1. Now we're going to do the same thing with triangle number 2, but here's where it gets a little tricky and some of my students have trouble seeing it. On triangle number 2, comparing it to the great big triangle, what angle do they have in common? B. So this angle B is going to match up with this angle B. So when I take that triangle and flip it, I've got to keep B up at the top. Do you see what I'm saying? So when I take this triangle and flip it to make the right triangle, B is up here at the top. What vertex is the right angle? D. And so it's B, D, C. And if you compare the big triangle to triangle number 2, do you see that they are similar by angle, angle similarity? And then by the transitive property of similarity, if the big one's similar to number 1 and the big one is similar to number 2, then that means number 1 and number 2 are similar to each other. So they all three become similar. So then to write this similarity statement, we can come back to our big triangle. Triangle BCA is similar to triangle. How would we name the next one? CDA, which is similar to triangle BDC. Now, if you don't see how to write them, how to turn those triangles and match them up, then here's a way that can work for you. So if you need more of a, more algebra procedure, I'm more of an algebra procedural person, this is what I need. Here's what I would do. I would start with my big triangle and I would name it. So somebody name the big triangle a different way. Don't name it BCA. ABC. Okay, this is the big triangle. So the big triangle ABC is going to be similar to, and we're going to name the first triangle here, triangle 1. So if you need a procedure, think about which one's the right angle in this picture. So which one's the right angle? A, B, C. Which one's the right angle? C. And because for triangles to be similar, the congruent angles have to be in the same location, then that means over here you're going to put the right angle. Does that make sense? In the little triangle 1, what letter is the right angle? D. So we put D over here. Then you're going to look for the reflexive angles, the angles that they have in common. So we're looking at the big triangle and the red triangle number 1. What angle did they have in common? A. Since A came first, I'm going to call that my reflexive angle. Then A has to come first. Reflexive angle. And then you just fill in whatever letter's missing. So I've got A, I've got D, so what letter am I missing? C. And you can do the same thing for the next triangle. But this time ignore the one in the middle. You're going back to the big one. The big one's right angle was C. So my right angle has to go here. What's my right angle in the little blue triangle? D. Now be careful. Triangle 2 does not have the same reflexive angle as triangle 1. So this was the reflexive angle for triangle number 1. Now what's my reflexive angle for triangle number 2? B, right? B is the one that the blue triangle and the big triangle have in common. So my reflexive angle for triangle number 2 is in the middle. So my reflexive angle for triangle number 2 has to go in the middle. What's the letter I'm missing in the second triangle? I've got B, I've got D. What letter's missing? C. You either need to be able to look at the picture and rearrange the triangles to write your similarity statement, or you need to match up your right angles and then go back and compare big to the triangle 1, find its reflexive angle, big to triangle 2, and find its reflexive angle. Questions on one method or the other? Okay, why are we doing this? The reason we're doing this is so that we can write proportions to solve for missing parts. So once we have the similarity statement, we could write all kinds of proportions. We could say BC over CD should equal AB over AC. Maybe we compare these two. Or we could compare any two triangles now and their corresponding sides to write proportions. That would be the long way to work the problem. You can do it that way if you want, or I'm going to show you shortcuts in a minute. But what you have to be able to do is write the similarity statement. Any questions on how to write the similarity statement? All right, we'll see if you can do it. Go to the next one in your notes. Right now, you and your partner write the similarity statement for these three triangles. And we'll see if you get it right. We'll see how you're doing. I'm going to pick on, let's go with Lily. Name the big triangle however you named it on your paper. Okay, so Lily said VWU, is that correct? Is that what you wrote? Okay, heads up, V and U. Some of you are not doing a very good job when you have a V and a U in your work, and I will not give you credit if I can't tell the difference. I would highly advise you to put a tail on your U, or make sure there's a sharp V and a very curved U, because some of you on your homework was not good. And on come test time, I'm not going to give you the benefit of the doubt. If I can't tell, it's wrong. So be very, very careful, okay? Okay, so going with what Lily did, I'm going to show what hers should have been, and then we'll check and see if you named yours differently, what it should look like. So if I go VWU, that means my right angle is in the middle. So on the next two triangles, her right angle should be in the middle. So I'm going to call this triangle 1 and this triangle 2. So the right angle on both of those is what letter? Z. So Z should go in the middle where the right angle is. At this point, be very careful. The reflexive angle changes based on the big one in the first triangle and then the big one in the second triangle. So I'm going to start with this first triangle. What angle do they have in common? U. U does not change at all in the big one or in the one on the left. So since U came last, we call that a reflexive angle for triangle number 1. U should come last here, reflexive angle for triangle number 1. That means this triangle on the left is called something ZU, so that something would be W. Then when I go to the last triangle, I'm looking for the reflexive angle it has with the first big triangle. So now when I look at the second one, what angle does it share with the great big one? V. Are you guys with me on reflexive angle? The angle that doesn't change size, it's exact same angle. So V here is my reflexive angle. Oops. Reflexive angle for triangle number 2. So that means over here, V has to come first. So it's going to be V, Z, W. Reflexive angle for triangle 2. Questions on how Lily should look? Okay, somebody tell me how you named yours differently to start with. What was the first way you named your triangle? Anybody not name it VWU? Devin, what'd you name it? UVW. So you went UVW, so it should be the same when I match it up to the rest of these. So it should be triangle UWZ, which means it should be the same as triangle WVZ. Does that make sense? Somebody name it a different way than Devin or Lily? Questions now on how we got this? Anybody confused? Okay. To me, that's one of the hardest things you have to be able to do is match them up. Again, visually, you can redraw the pictures if that helps you better. So you can redraw them and then write your similarity statement. All right, I'm going to skip this example unless we need to do one more. Does anybody want me to go through one more example? Okay, then I'm going to skip it. It is in the filled-in notes, so tonight when you're at home, if you were kind of afraid to ask, go back and try this one and look at the answer key on your filled-in notes. Okay, so geometric mean, we're going to talk about what this is, and then I'm going to show you why we're learning it in a second. So first of all, they're going to ask you to look at this proportion. This proportion gives us A over X equals X over B. In this case, the means of the proportion are the same number. Now, I don't know if you guys have ever learned this, so you may want to write this down in your notes. This is called the means diagonal, and this is called the extremes diagonal. So if they're talking about the means versus the extremes go down from left to right, the means go up from left to right. It's not something you're really going to have to memorize, but to understand this paragraph, you need to know that information. Okay? So it says, consider the proportion. In this case, the means of the proportion are the same number. Do you guys see that these are the same X and X? And that that number is the geometric mean of the extremes. So what they're saying there is X is the geometric mean of A and B. Okay, that number that's in that diagonal will be the geometric mean of A and B. What is the geometric mean? The geometric mean of two positive numbers is the positive square root of their product. What does product mean? Multiply. So in other words, if I wanted to solve this proportion, I would cross multiply. What is X times X? X squared. And then A times B would be A times B. If I want to solve for X, what would I do? Stay with me. What would I do if I want to solve for X? Square root. We learn in Algebra 1, though, when you take the square root, you're supposed to put positive or negative. But the directions or the definition says the geometric mean is not plus or minus. The geometric mean is just the positive square root of their product. So when I solve for X, X is going to be just the positive square root of their product. So geometric mean definition is a shortcut so that you don't have to write the proportion every time. You can just simply multiply the two numbers, take the square root. If they give you two numbers and ask you to find the geometric mean, all you do by definition is multiply them and take the square root. That is your geometric mean. Okay, are you with me? So means go up, extremes go down. If your mean is the same number, you can find that number by multiplying your extremes and taking the square root. Look at the next example. This question just says, find the geometric mean of the pair of numbers. Again, I'm going to tell you, you could write a proportion, but you don't have to every time. If I wrote a proportion, 5 and 30 would go in the extremes spot. And I'm looking for the geometric mean, which would be the same number, so it goes in the means spot. But I don't need to do that and then cross multiply. I can go straight to the definition. The definition says the geometric mean is the product of the two numbers, take the square root. How would we always leave our answers? Simplest radical form unless it says to round. So don't grab that calculator. It's not going to help you at this point. You need to do this by hand. Simplest radical form. The only time your calculator would be helpful is if this was a perfect square root. So if you wanted to check and see, is the square root of 5 times 30 a whole number? You could. But if it's not a whole number, you've got to go back and do it by hand. Okay, what's 5 times 30? 150. You could simplify it to 150. But then you're going to have to factor it back out because it's not a perfect square. So you may want to leave it 5 times 30 and just factor it from there. It's up to you. What goes into 150? Does anybody see the biggest perfect square? 25. What is 25 times to get 150? 6. So that's probably the fastest way. Take the square root. What's the square root of 25? 5. can't take the square root of 6, so my answer would be 5 square roots of 6. If you don't think about the biggest perfect square, because some of those numbers could get large, if you leave it as 5 times 30, remember you could simplify it this way. Keep the 5. What does 30 factor into? 5 times 6. 6 factors into 3 times 2. I've got a pair of 5, so that comes out front. I don't have any pairs for 3 and 2, so those go back underneath the radical multiplied together. So whichever way is easier for you. But my answer for the geometric mean is just the square root of the product. Questions on geometric mean? All right. Trying to show you some different things, and then I'll connect it together for you. Oops. Okay, so here's where these two things collide. Why are we learning two different things? So we know how to write the similarity statement. And now we know what geometric mean is. Geometric mean in a proportion is the same value along one diagonal, and it's found by multiplying the other diagonal and taking the square root. Look at this up here at the board. Try not to focus on your notes for a second. Look up here. Do you see this great big triangle? Divided into two right triangles, right? What they are doing is they are writing a proportion comparing parts of their triangles using the similarity statement. So what they're saying is that B over A would equal Y over H, which is the same as H over X. This comes from comparing the three triangles. What I want you to see is the part in red. So we're only going to focus on the part in red. If I were to write a similarity statement and I came up with this proportion comparing our parts, do you notice that this is the same number? H and H, right? So this is going to lead us to our first shortcut. H would be the geometric mean of Y and X, right? So H would equal the square root of Y times X. Now I want you to look at where H, Y, and X are. H is the altitude. Y and X are the parts of the big hypotenuse. Do you see that? So part of the hypotenuse times part of the hypotenuse. You with me? They're not going to write it this way. They're going to write it as H squared equals X times Y. So they're going to say altitude squared equals part times part. Okay, that's kind of confusing, so let's look at it again for another scenario. Now when I compare big triangle to this triangle, I end up looking at only the part in red for me right now. What's the geometric mean letter here? A. So we're saying that A squared is equal to CX. Are you with me so far? Okay, I'm going to go back. This is going to give us our second shortcut. First shortcut is this one. This is going to give us our second one, and this is another example of the second one. So the first shortcut says you can take the altitude and square it, and it will equal part of the hypotenuse times part of the hypotenuse, and you can skip this whole writing a similarity statement and comparing your sides. This one says A. What was A over here in the big triangle? It's not the altitude. It's not the hypotenuse. What is it? It's what? A leg. This is going to say that the leg squared is equal to, what is C over here in this big triangle? Not big C, little c. Little c is the hypotenuse. So this is going to say leg squared equals the hypotenuse times, what is X in this picture over here? What is X? In the big triangle, what is X? Part of the hypotenuse. Every time refer back to the big triangle. So it's going to be part of the hypotenuse, but not just any part. It's the part that touches the leg we're looking at. So it's going to be part of the hypotenuse adjacent to the leg. In a right triangle, how many legs do you have? 2. So this is the first example of what it could look like with the leg on the left. Here's the second example where we're using the leg on the bottom. So again, look at just the part in red here. What do they have in common? What's our geometric mean? B, right? So this is saying B squared would equal C times Y. What's B over here in that picture? The leg on the bottom. So it's going to say leg squared is equal to, what is C in the big triangle? Hypotenuse times Y. What is Y in the big triangle? Part of the hypotenuse, but which part of the hypotenuse? The part that's touching this leg. So it's still going to be part of the hypotenuse adjacent to the leg. So, all of that to show you this. These are your 2 shortcuts. These 2 shortcuts only work if you have what kind of triangle? Right triangle. And in that right triangle, you have to have drawn an altitude to the hypotenuse. If that's not true, you cannot use these shortcuts. Okay, everybody up, focus with me, look at the board. This is super important. If you didn't write it down on the last example, write it down here because you're not going to remember this or this. But you might remember things like leg, altitude, part of a hypotenuse. So the first shortcut says the altitude squared should equal part of the hypotenuse times part of the hypotenuse. So part hypotenuse times part hypotenuse. So everybody with me on that first shortcut. So you can take this altitude and square it and set it equal to this times this. Every time if it's a right triangle with an altitude drawn. That's your shortcut. Second shortcut is this one down here. Notice there's 2 options because there's 2 different legs. This shortcut says leg squared will equal, so if I'm looking at A, that's a leg, or if I'm looking at B, that's a leg. They will equal the whole hypotenuse C times the part that's touching the leg we're looking at. So it is leg squared equals the hypotenuse times the part of the hypotenuse adjacent to the leg. Okay, I'm going to see if you're paying attention. I'm going to draw a different picture using different letters up here. Let's see if we can write our 2 shortcuts. And so we're going to look at some examples, and that's really the end of the lesson, just practicing problems. So when I look at this picture, let's go A, B, C, D, E, F. Somebody give me the first shortcut with the correct letters. B squared, altitude squared, equals C times D. So everybody with me here. This squared equals this times this. We good? Okay. Last one here. Give me the second shortcut using leg A. A squared equals C times F, or F times C. It doesn't matter what order we multiply in, right? So leg squared is equal to the whole hypotenuse times the part touching the leg. What would that be for the other leg E? E squared equals D times F, or the whole hypotenuse F times the part touching D. Do we all see those shortcuts? Okay, worst case scenario, you forget the shortcut. You've got to try to redraw the triangles and compare parts and write proportions. If you can remember these 2 shortcuts, it saves so much time. So let's look at some examples. First one. Do we have a right triangle? Yes. Do we have an altitude drawn from the right angle? Yes, so now we can use the concept of geometric mean to find missing parts of our triangle. You may have to find, I'll give you a warning, you may have to find a part they don't ask you for so that you can find a part that you need to find. So be careful there. Also, what did we learn a long time ago with right triangles that we could use on any right triangle? If we knew it was a 30, 60, 90 triangle or a 45, 45, 90, do we know anything about angles on this? Not today, but those are good things. What else did we learn about right triangles? Pythagorean theorem, and you will probably want to use Pythagorean theorem on some of them today because it'll make it easier, okay? But I'm going to practice these more than I am Pythagorean theorem. Anytime you know two sides of a triangle, though, you can use Pythagorean theorem. Okay, take notes. Look up with me here. We want to find x, y, and z. Which one of those could we find with Pythagorean theorem? Z. Does everybody agree? We know 9, we know 6, we could do Pythagorean theorem. I'm not going to do that because I'm trying to practice this shortcut, but we could. Let's try to find a different one first. So I could find x because I know the altitude, I know a part, and I'm looking for the other part. That is our first shortcut. Altitude squared equals part times part. So set it up for me, Jedi. What's my equation? Very good. So everybody with Jedi here? 6 squared equals 9x. So 36 equals 9x. Divide by 9. What is x? 4. Circle it. That's part of your answer. Plug it into your picture. What does that make the whole hypotenuse now? 13. Okay, again, I'm going to try not using Pythagorean theorem just so I can practice these shortcuts. But anytime you see Pythagorean theorem, you could use it. So now we technically could find y using 4 and 6, right? And do Pythagorean theorem. So you can use it if you prefer it, but for today I want us to practice the shortcuts. So how could I use the shortcut to find y or z? Which one do you want to do first? Okay, let's do y. Somebody tell me how I could set up a shortcut using y. Talk to me, guys. Y is a leg. So it's leg squared equals whole hypotenuse times the part touching the leg. What would that look like here? Y squared equals 13 times 4. You're going to have to use these shortcuts sometimes, so it's important that you can see them in the picture. Leg squared equals the whole hypotenuse times the part touching y. Okay, so now we have y squared equals what? 52. Take the square root. Only positive answers for side lengths. And then simplify, simplest radical form. What do we get? Should be what? 2 squared root of 13 because this is 4 times 13. Square root of 4 is 2. Square root of 13 doesn't simplify. So y is 2 square roots of 13. Okay, let's try it again. Somebody different, help me find z using the shortcut. And beware, if you're not talking to me, I'm going to call on you. Go for it, Martin. Very good. Leg squared equals the whole hypotenuse times the part touching the leg. So 9 times 13. What's 9 times 13? What is it? 117. Does anything go into 117? Nothing? 3 does, right? How many times does 3 go in there? What is it? 39. And then 39 factors into 3 and 13. So actually 9 goes into 117, right? 9 times 13. Okay. So what does this simplify to? 3 square roots of 13. Because this would have factored into 9 times 13. The square root of 9 is 3. So be careful. Some of those numbers can get big and ugly, and you just need to check You've got a calculator. You'll have a calculator on the test. Any questions on this one? All right. I want you guys to try the next one with your partner. See if you can find U, V, and W, and then we'll check it. And if you're having trouble, please ask me so I can help you one-on-one. And then we have one more example and we'll be done. Let me remind you, this homework, you're going to forget your shortcuts if you don't practice it a little bit tonight. But this homework is not due Friday. This homework is not due Tuesday. This homework is due when? Thursday. But you're also going to have a quiz on Thursday over segment partitioning, the construction and the algebra. So I would try to do this assignment if I have time, but my focus is in getting ready for the Chapter 7 test, and this is not due till next Thursday, okay? So just want to warn you, you're going to have lots of time to work on it. All right, U, V, and W. How many people found V first and did Pythagorean theorem? Okay, and that's totally fine. How many people found U first? All right, it does not matter. You can find both of them right now. I could find V by using Pythagorean theorem. 3 squared plus 9 squared should equal hypotenuse squared. So 3 squared plus 9 squared equals V squared. You could have also found U first and then done the shortcuts to find V, whichever makes more sense to you. I'm not going to work it this way because I'm going to practice shortcuts. U. If I use my shortcut for U, it's altitude squared equals part times part. So it should have been 9 squared equals 3 times U. 81 equals 3 times U. Divide by 3, U equals 27. Questions on how we found U? Once you find U, if you plug it in up here, what does that make the whole hypotenuse? 30. So now I'm going to go back and find V the other way using my shortcuts, just to practice that. So V is a leg. V squared should equal the whole hypotenuse 30 times the part touching V, which is 3. So that gives us V squared equals 90. V equals the square root of 90, which is 9 times 10. So that is 3 square roots of 10. Questions on V? Okay, and then we go back and we want to find W. You could use this 3 square roots of 10 and do Pythagorean theorem. Be careful if you do it that way. Or you could find W by doing your shortcut again. Leg squared, W squared equals the whole hypotenuse 30 times the part touching W, 27. That gives me W squared equals, I'm going to leave it as 30 times 27 and then take the square root. I don't know why I wrote it again. Just because that's not, is it a perfect square? It's not, right? Okay, so I would leave it like this and then just factor, make it a little easier on myself. This is 3 times 10. This is 3 times 9. 2 times 5. 3 times 3. Pair of 3s. Pair of 3s, and a 2 and a 5. When you bring out 2 pairs, what do you do with them? Multiply. So that gave me 9 square roots of 10. But you could multiply it and then refactor. It's up to you. Questions? Are we good? All right, last example. Look at the word problem. Surveyor positions himself so that his line of sight to the top of the cliff and his line of sight to the bottom form a right angle as shown. You may have to draw a picture on your homework. If you do, you're right here. Your line of sight means you're looking from your eyeballs up to the top or from your eyeballs down to the bottom. Together, those form a right angle. Then we have his line of sight straight to the cliff. Oops, I'm so sorry. That makes an altitude. They tell us his line of sight straight to the cliff is 28. They show us that this distance here is 5.5, and they want to know what's the height of the entire cliff. So what's this height? This little piece is 5.5. We could solve for this piece x. And then what could we do with those two pieces? Add them together. So what would I write down using my shortcuts to find x? That's not the one I'm writing. What would I write down, sorry? 28 squared equals 5.5 times x. Altitude squared equals part times part. Okay, help me out. What is 28 squared divided by 5.5? Nearest foot? 140 what? 143? Somebody check it with Jedi and agree? Okay, is that my answer though? No, so should I really have rounded right then? No, what was it again, Jedi, before you rounded? Oops. 142.544444, keep going? No, 5454 repeating? Okay, so that's repeating. So we want to add the 5.5 to that. And then we want to round. So what do we get when we add those together and round? 148. Okay, so to the nearest foot would be 148 feet. Questions? All right, that is it. So you have